So to start off, we're going to look at a review of some of our vocabulary that's going to be helping us through this unit. So the first thing that we want to remember is variable, and a variable is an unknown value, and it's usually represented by a letter. So those are those X's that I have underlined in pink there. And then the other word that we want to use that does not contain a variable is a constant. So a constant is going to be our 32 there, and that is our number that does not affect or is not affected by the variable. Now I highlighted that plus sign with it to remind you, always look to the left of that number to see whether or not that's positive or negative. Another vocab word you want to keep in mind is coefficient. Coefficient is the number that's placed to the left of a variable and it multiplies it. So in this case we have 4x squared, so 4 is the coefficient. And then right here we have negative 6x, so negative 6 is that coefficient. Now you might say, well, that looks like minus 6, but again, look to the left of that number, of that term, and that'll tell you what kind of positive or negative number that is. So this is a negative 6 here. So coefficients are those numbers that are highlighted in green here. The last thing that I have is marked in yellow, and that is our exponent. So I'm just going to draw an arrow to that. Remember, an exponent tells you how many times you're multiplying something by itself. So in this case, x would be squared. So you'd be taking 4 times x as this whole term here. And just as a reminder, each of these individual pieces here are terms then. So 4x squared is a term, 6x is a term, and 32 is a term. So the question then becomes, what are like terms? So that's going to be a term that you're going to be hearing is like terms. So a like term, an example of that would be if all of your terms had y's in them. So negative 3y, 2y, or y. And you could even see y to the first. This is going to mean all the same things. These are all just y's, and it's just one y. All right, now we could also have 4x squared, like we did up top here. Something that would be a like term to that would just be x squared, or 1x squared, or even negative 2x squared. So all of these would be like terms because they all contain that x squared there. One final example would be with constants. We would have 3, we could have 45, 32, negative 2. Any of these would be like terms because they're all just constants. So the like term in the first example that I wrote there would be y. The like term in the second example would be our x squared. And then in our third example, they're all just constants, so they don't have a variable with them. So when we're talking about like terms, you want to keep in mind what the variable is, if there is one, and then what the power of that variable is. So in this case, y was just raised to the first power, or with no exponent there, it means the same thing. Or in the second case, we had x squared, so all those x's were raised to the second power then. So that's just an intro to what like terms are. So some tricks to remember, I kind of already mentioned this, but no exponent is going to mean it's an exponent of 1. So what I mean by that is if you see y, this is the same as just saying y to the first power. An exponent tells you how many times you multiply something by itself. So if you just have y, you're just multiplying it by nothing. It's just itself. So y to the first power is going to mean the same thing. Now you typically are going to see it more in this form of just y, but this is just something to keep in mind. This would be the same for any variable you would see, so it could also work with x, a, b, c, etc. Now similarly, if you don't see a coefficient on a variable, it's going to mean that it's a variable of, or a coefficient of 1. So if you just see y, that's the same as 1y. So remember our rule for the identity property of multiplication. Anytime you multiply 1 times something, you just get itself. So y is the same as 1y because 1 times y is just y. So that's why that works. So again, if you would see x, this would be the same as 1x. Now, this is just kind of an intro to that trick, but something else to keep in mind, you could always also see negative x. That would mean negative 1x. Okay? So that's just something to keep in mind. Now, if we're trying to combine like terms, it's really important that you always look to the left of a term to determine if it is negative or positive. If you're not looking to the left, you could miss a negative sign, and that's going to change the answer that you're getting, which could lead you to an incorrect final answer. So we'll look at that in the next few examples to let you know what I mean by that. So in this first example, we just want to combine each term, like all the like terms, to simplify each of these expressions as best as we can. So I have 7x plus 2x. So when I look to the left of 7, there's nothing there. That means this is positive 7x plus 2x. So I have positive 2x's right here. So this is just in longhand notation here. I would have x plus x plus x 7 times, because that's coefficient is just telling me that I have 7 x's here, right? But then my 2x is telling me I'm going to be adding 2 more x's, right? If I add all these together, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So my final answer becomes 9x. Now, if you want to think about it in something more concrete, you could think of 7x as 7 xylophones, and then you have 2 other xylophones. So altogether, you would have 9 xylophones, so 9 x's there. Okay? All of these were able to be combined because these were each just x's and they didn't have an exponent, so we just had to combine their coefficients to figure out what they simplified to. Now if we look into this next example, we have 8x squared, we have plus 3x, plus x, and then plus 1. So we've got 3 different types of terms here. 8x squared is the only term that I have that has an x squared in it, so there's nothing that I can combine with that. But then I have 3x and x. Remember that x is just the same as 1x like we saw above here. So really this is like having 3x plus 1x, so in total that gives me 4 x's. And these both had a plus sign to the left of them, so those were positives. My last number in that original expression was a plus 1, that was just a constant, so there's nothing that I can combine with that one because it's the only constant that we have in our problem. So now all of our terms are different types of terms, so this is the most simplified form that we can put this expression into. Now if we get down to the bottom here, it gets a little trickier. So I have negative 9x squared, so notice to the left of this number we have a negative sign, so we're going to have to keep track of that. And then I have minus 8y, which means I have negative 8y, plus 1, there's a constant, minus 4, another constant, and then plus y is another y term. So I'm color coding all these just to help you see it a little bit better, but what you might want to do when you don't use colors is just rearrange the order in which you're seeing all of these to put all these terms next to each other that are similar. So negative 9x doesn't have any friends, or it's the only x there, so I'm going to put him down first. Then I'm going to bring down the negative 8y, and then my plus y is going to go right next to that. And remember, if you want, you could always add a 1 there to remind yourself, okay, that means that's 1y. Didn't really come up very well. And then we had our constants. So we have plus 1 and minus 4. So all I did in that step is just move things around so I could see these things next to each other. Now I'm going to combine my like terms. So I have negative 9x, and then I have negative 8y plus 1y. So I need to remember this is a negative 8. So if I have negative 8 and I add 1 to that, that gives me negative 7, so that means I have negative 7y. And then for my constants, I have plus 1 minus 4. So positive 1 minus 4 is going to get me to negative 3. So all said and done, this is the most simplified I can put this expression into. I've combined all my x's, there was only one x term, combined my 2 y terms together, and my 2 constant terms together to get negative 9x minus 7y minus 3. So for our final example here, we have 6y plus 5x, so those are already going to be different terms, minus 2y, so that's a negative 2y there, and then minus 3x, which is a negative 3x. So the first step that I'm going to do is rearrange the order in which I'm seeing these so I can put my like terms next to each other. But be careful with this negative 2y because it says minus 2y, so we have to treat that like a negative 2. We bring down our plus 5x and our minus 3x. Now we can combine our like terms since they're right next to each other. So I have 6y minus 2y, so if I have 6 yellow crayons, say, and I take 2 away. Now I've only got 4 yellow, so 4y, plus 5x minus 3x. So I have 5 xylophones, take 3 xylophones away, so I have 2 xylophones left over, so that's a positive 2x, and now I've combined all my like terms as best I can. All my y's were put together, and all my x's were put together.